Okay, welcome back to the Sankey diagram tutorial. This is part 3. If you haven't seen parts 1 or 2 yet, you'll want to start there because we're about to dive right in. So if you recall, we got to the point where we have a Sankey diagram that is generated based off of data from Flexsim global tables, specifically this nodes and links table. So that's great. We've got this static these static values here. I can open the GUI and see those values in a graphical way. If the tables change, like maybe this becomes George, and maybe our value here changes from 7 to 77. Next time I open that diagram, I'll see those changes there. So you see we've got a George and we've got a 77. So pretty nice. We can type new data in and we can see those changes right away once we reopen the diagram, because this diagram is only generated that first time when you open the GUI. So wouldn't it be great if you had some Flexsim model that would actually build these tables kind of on the fly, so that you're watching a model and you could say, hey, let's check out what the diagram's doing, and open the diagram and see the current state of the model as represented by that diagram. So that's what we'll do. To accomplish that, let's just copy our GUI here. We'll call it GUI 2. So we're going to keep this static GUI. We're going to keep these static data tables, but we'll also add some new dynamic ones. This GUI 2 will be our dynamic GUI, dynamic data, and then we'll make some new global tables. I guess we can just do that here. We'll call this dynamic nodes. It's got to have string data for names. Right? This is our dummy row. And then we'll do one more for dynamic links. And we've got to have 3 columns. And that's what we need there. Okay, next step would be, let's make a very, very simple model. Source, 2 processors. How about a queue in between for good measure, and then a sink. Okay, so there's a very simple model. Now what we'd like to do is populate this dynamic nodes and dynamic links on the fly as the model's running. Okay, so the first thing we'd do is, let's say the on entry of this queue, we want the queue to check in and say, hey, I'm one of the nodes in this model run. Okay, so to do that, first off, we want to have a number label, and we'll call this its Sankey index. And then in triggers, in the on entry, let's just code up our own stuff here. But we'd say, when we have an object enter here, let's go ahead and check what our Sankey index is. So we say int Sankey index, and we'll just read it off of our label. Get label num current Sankey index. Okay, now if Sankey index is equal to 0, that means we are not yet in the nodes table, the dynamic nodes table. So in that case, we would want to say set table size of the dynamic nodes table to be get table rows of dynamic nodes plus 1. And then there's only one column in that. All right, let's do things just a little bit more efficient code-wise. Say referencing tables by name all the time is kind of slow, so we'll just do it one time and then use that reference throughout instead. And then also we want to keep this new Sankey index number. Whoops, I don't need to declare it again. But we'll say it'll be the next row of that table, right? Boom. So we'll increase the table size there, and we'll say set table string for dynamic nodes on that row, on that column, and the value will be the get name of this object, in this case the queue. And then we also want to set label num on this current object, Sankey index, to this Sankey index value. Okay, so now this object knows, hey, I am in the dynamic nodes table. We're good. And this is the row I'm at, Sankey index. Okay, now let's just see this. Now remember that the dynamic links, you've got a source and a target, and this is the queues on entry. So there must have been, that makes it the target. Now there must have been a source. Where did this flow item come from? And that would be the upstream object. So we've got to do the same sort of stuff for the upstream object. In fact, I'll check the upstream object first. Okay. So we'll call it the in object, and it's a tree node actually. So we use the, oh, I'm having a hard time here. We use the in object command to reference upstream objects. So in this case, it's the in object of our current object through which port, the port that the flow item came through. Okay. Then we want to get the in object's Sankey index, and it'll just look a lot like this will. We'll just change this to in object. Alright, so then if we don't have an in object Sankey index, then we'll do all of this. Alright. Get name of in object. And this will be in object. Okay, I think we got everything there. So we first will put the upstream object into the Sankey, or to the dynamic nodes table if we need to. Then we'll put the current object into the dynamic nodes table if we need to. Then let's see if there isn't already a link to that connects these two objects. Now, how are we going to check that? Easiest thing would be to have another label that does that. So what we'll do here is we'll say Sankey links. Now what we'll actually want to do is make this be a label table. It'll have a subnode for every to apply that. How do I get the set size? Oh, here we go. What we need here is a row for every input port going into that queue. So right now it's just one row, and we want to have two columns. One column is going to be the value. It's the number of flow items that have gone from the source object to this target object. And then the other column, we'll call that the value column. And then this column is going to be our link index. So if you're looking at the dynamic links table, it's what row number this this link from source to target is related to. Okay, so let's do this. Check to see whether there is a row in the dynamic links table for this link. Dynamic links. Okay, so what we need to do is check this label table. Let's get the label itself. Tree node, what do we call it? The Sankey links. Oops. Okay, now we want to use that and say if there's a link index there. So we'll say int link index, do the underscores, is equal to get table num from the Sankey links label table. The row is going to be port, and the column is going to be 1. Now, if there's no link index, we'll do it this way. If we have never added a link index row, then we need to do that first. So we'll say link index is equal to the get table rows of dynamic links plus 1. Add the new row in. Then we'll set the table size to that new number of rows. And there's 3 columns in the links table. Then we need to set the source and the target. So we say set table num on the dynamic links. The row is link index. Column 1 is the source. And remember, the source's row is the Sankey index. We need to do the same thing for the target. Oh, and I did the wrong. So the Sankey index is the target, and the in object is the source. Okay, and then the value. We won't set the value within this if, because we'll need to set a new value regardless. First thing we'll do is we'll say increment get table cell of Sankey links. The row is port, the column is 2. We want to increment by 1. So keep in mind where we are. We're in the queue's on entry trigger. On entry means a single new flow item just came in, and it came in through the port given to us by the port variable. And so what we want to do over here in this label table is, remember, we'd have say if there were 4 input ports to this queue, we'd have a table like this. And this is just telling us an index into the global table, the dynamic links table. And this is telling us how many flow items have come in through the given port 1, 2, 3, or 4. And so this is just an incrementing value. Every time something comes in through a port, we increment the value that's in this column for that port. So that's what I just did right here. We increment that value, and then I need to, in the dynamic links table, set that new value. So 3, this will be get table num from Sankey links port and column 2. Okay. Now that's pretty much it. We've added the in object and the current object to the dynamic nodes table, and we've added we're tracking the flow item flow with this dynamic links code. Okay, now we actually need to do this for every object. So it would be smarter, yeah, no errors, so we'll just copy this out of here. It'd be smarter for us to go ahead and make a user command that we can just reuse everywhere. So we'll call this the Sankey object on entry. And we need to pass in item, current, and port. Those are the same three input parameters that any on entry trigger gets. Let's put the code in before I lose it from my clipboard. Okay. So we've got tree node item is going to be par node 1. This is just how you get the parameters into a user command. If you've never seen this before. The first, second, and third par val input parameters. Okay. Okay, we're good there. Just save my model real quick. And now we want to put our example in here. And then we'll just go ahead and put that in the queue. Oh. Okay. Okay. Put it in each of the processors. So there's actually ways we could just copy it to every object. Should be smarter. Maybe let's do that for the rest. We want to say edit selected objects. We'd like to copy a particular variable, the entry trigger. If you see it call out, oh look, it's alphabetical. Entry trigger. Variable. Yes. Okay, so we should see that in the entry triggers here. Yeah, we're calling it. Okay, now just to check that this is doing what we want it to do. Oh, another thing. One last thing before we test things is right now we've got a dummy row and a dummy row here. We'll run the model and it will start populating, but when we reset and run again, it'll just continue populating. We're never resetting these tables. So in order to reset those tables, let's just make a model trigger on reset, and we'll say, we'll just get a couple of references to the tables. Struggling. Okay, and then we'll set the default sizes. So set table size for dynamic nodes. Yeah, one row, one column. And links has 3 columns. Okay. So we'll save it, reset, and run. Ooh, we've started to populate some things here, and we're populating some things here. Good. Look at this. Got a problem. Got a problem. Okay, so remember our user command. It's checking these labels, right? Right here, get label num off the current object. We didn't add labels to all the objects. Great, huh? We need to go do that. So we could do it manually, or we could do it in the model on reset and dynamically add those labels everywhere we need them. What do you think? Let's do that. Let's go back to our on reset of the model. Let's do this, some comments. Okay, there's actually a great command called for object tree under, and you say model. So what this does is just loops through every object under the model node. So the first thing we want to do is we only want to look at fixed resources. So we'll skip anything like operators or objects that are not otherwise fixed resources. So we'll say if is class type. You get this a variable. As you're looping through, a is the current object that you're looking at in this iteration of the loop. And we're looking at class type fixed resource. So if it's a fixed resource, we want to do some stuff. If it's not, then we'll skip it. The other thing, we only want to add labels to objects with entry triggers. Some fixed resources, the source obviously don't have entry triggers. There might not be any others, but we'll just be consistent. So we only want to only want to add labels, add or reset labels on objects with entry triggers. So we'll say tree node on entry trigger is equal to the get var node of a. The variable is entry trigger. So if object exists on entry trigger, so if there's an entry trigger, then we'll do some stuff. And the stuff we want to do, there's this great assert label command that will either create a label if it doesn't exist, or if not, it'll just won't create a new one. Just make sure one is created. We'll call it the Sankey. What did I call those? Sankey index was the first one. And it's got a number data type number. Right, that's all the parameters, yeah. Okay, and let's get a reference to that label. Sankey index. And then we'll just initialize it. I guess it's already a tree node, right? We don't need to do all that. We'll just do a set node num. We could have done a set label num, but I'm already where I am, so yeah, value 0. Okay. Now we need that inputs table. Now is that what I called it? Who can remember? Raise your hand. Labels, links, Sankey links. So we'll do the same thing here. Say Sankey links. So this isn't just a regular label, it's a label table. So what we need to do here is say set table size of the Sankey links table, label table. How many rows do we need? We need the number of input ports on the object. And then how many columns? We just need 2. Okay. I think that's all we'll need to do for let's do this. In case it already had a table underneath it, let's just go ahead and clear it. That way it'll be reset if there was already a table. Okay, so that'll do. After we fix the error, of course, get var node. Okay, so model on reset is done. I just hit reset, so now all of those objects should have the labels we want. Yes, and this links label table has 2, just like it has 2 input ports, so perfect. Let's watch it run. Dynamic nodes. We should never have more than 4 objects in here, since that's all we have in the model. Ooh, wait a minute, 5, yeah, 5 objects. So yeah, we're not getting any other objects. And there's only so many links also, right? Ooh. Looks like we're duplicating here. For instance, here's a 2-3 and here's a 2-3. That shouldn't happen. So that would be in the onEntry user command. It's adding too many links, or perhaps let's check out our objects here, labels. If we look at the label tables, we're not setting that value. Did we forget to do that? Let's see. Set table num, dynamic links. Yeah, we never did a set table num in the label table, which is called Sankey links of the row we want is link index, and the column we want is column 1, and we're going to put the it's not link index goes out here, and this is port. Good. Okay, let's try that. Alright, this is do or die time. I think we've got it now. Let's watch these dynamic links. Yes, we got it. Okay, so we're generating these tables on the fly. We don't yet have a Sankey diagram that's looking at dynamic nodes and dynamic links. So, but we do have this GUI 2 that's really close to doing that. We just need to change a few things. Okay, so let's dive in there. Look at the on pre-open. Remember, that's where we take the global tables and generate the JavaScript code that was in the previous tutorial. Okay, so we'll change these to different global table names. And there's one other thing we need to do. Remember before our data started on row 1 and we had to account for that? Well, guess what? Our data now is starting on row 2. Because it's in a global table that gets reset, we have to have a dummy row in both of the tables. Okay? We've got to account for that in both of the tables. So what we do in our on pre-open over here is right here, we need to start at row 2 when we're populating the nodes array. And then here we can start at row 2, but we need to subtract 2 off of the index to make it zero-based again. Okay? I think that's all we've got to do. Well, let's test it. First we'll build up some data. That should be fine. Okay, ready? Oh, you know what else we need to do? Let's tie GUI 2 to our model control button. And now when we hit this, it should open GUI 2. And look what we've got. We've got our very own data. Source, queue, 2 processors, and a sink. Pretty nice, huh? Okay. That finishes up tutorial number 3. Tutorial number 4, we want to look at updating this graph while the model's running. Okay, that'd be pretty cool, right? So right now the model runs, but these values are never changing. I've always got 17 flow items going from source 1 to Q4, regardless of the fact that our model is changing. Now if I reopen this GUI, this new version is going to have the updated numbers. So that's because we're generating the chart, the diagram, at the time we open it. So in the next tutorial, we'll update the currently open chart with fresh data as it comes through. Thanks. Stay tuned for part 4.